All right, in your instruction book, we had to do pages 10 and 11. These are the problems that are the most similar to what your quiz will be today. On number 1, which expression is equivalent to -4 to the -5th to the 0? Notice the 0 exponent. Everything inside of that group to the 0 power becomes 1. The answer to this one was A. How many of you got this one? Good. Anybody have a question before I go on? All right, number 2. Which expression is equivalent to 7 squared to the 5th over 7 to the -6th? I would start in the numerator because you've got that double exponent there. You've got 7 squared to the 5th. Use that power rule and keep the 7, keep the base, and then 2 times 5 makes 10 over 7 to the -6. Once you simplify that, you're looking at a quotient rule, and we need to subtract the -6 from the 10. So 7 to the 10 minus -6 over 1, because we just got rid of that one. Now, 2 negatives make a positive, giving us 7 to the 16 over 1, which is the same as just 7 to the 16. How many of you got this one? Anybody have a question before we go on? Number 3. Which expression is equivalent to 1 over 49? Select all that apply. Now, we do these in this book because this is what your Tennessee Ready test likes to do. It likes to do a select all, choose all, pick all. So you are looking at basically 5 different questions here. This is 5 different problems. On your quiz today, if you see something like this, each one of these would be graded separately. So if you miss one of them, it doesn't mark the whole problem wrong. It just marks that one wrong. What you're going to have to do is you're going to have to simplify all 5 of these answer choices to see which ones come out to 1 over 49. On A, you've got 7 to the -1 times 7 to the -1. That is a product rule. You're going to keep the 7, and you're going to add the -1 and -1. So -1 plus -1 becomes -2. We cannot leave a negative exponent. Make it a fraction. Flip the reciprocal, and you end up with a positive exponent. Now, we're close, but we still don't match 1 over 49, so go ahead and simplify 7 squared. 7 times 7 makes 49. So A is correct because it matches 1 over 49. On B, we've got 7 to the 8th times 7 to the -6. Again, we're using that product rule. We're going to keep the 7. We're going to add 8 plus -6, which will give us 7 squared. 7 squared is 49. Is 49 equal to 1 over 49? No, it is not. So B is not correct. On C, 7 to the -5 times 7 to the +3, product rule, keep the 7. Add -5 plus 3 to get 7 to the -2. We had 7 to the -2 here, and it worked out correct, so C is also correct. On D, 7 to the 7th times 7 to the -9, product rule, keep the base. Add 7 plus -9 to get 7 to the -2. If 7 to the -2 was correct in C, it is also correct in D. On E, 7 to the -2 times 7 to the +4, keep the base. -2 plus 4 makes 7 squared. We've already said that 7 squared is 49, which is not equal to 1 over 49, so E is not correct. Did anybody get all 3 of those choices correct? Does anybody have a question before I go on? All right, number 4. Write 16 to the 8th as a power with a base of 4. Do they want us to change the exponent or the base? They want us to change the base. So for now, just set the exponent off to the side. We want to change a base of 16 to a base of 4. How is 4 and 16 related? How could we use 4 to get 16?
4 is the square root of 16.
4 is the square root of 16. So 4 times 4 would be equivalent to 16. So if we take out the 16 and we plug in 4 times 4, we could write this as an exponent, and we would have 4 squared to the 8th. Now, our base is 4, just like they wanted. Go ahead and simplify that, and you get 2 times 8 is 16. 4 to the 16th is what you're looking for there. Number 5 is also a multi-part question. Each part would function as a separate question on your quiz. Look at the equations below. Choose true or false for each equation. 2 to the 4th times 3 to the 4th is equal to 4 to the 6th. Now, these bases are not the same, but the exponents are. So I'm going to work with this side over here. I'm going to pull off the exponent, which is going to give me 2 times 3 to the 4th, which will give me 6 to the 4th. Is 4 to the 6th equal to 6 to the 4th? It is not, so it is false. On B, I've got 5 squared divided by 5 to the 3rd, and they want to know if it's going to equal 1/5. Now, 1/5 is in simplest form, so we need to work with this one. Typically, we write our division as 5 squared over 5 to the 3rd, which would tell us it is the quotient rule, and we need to subtract. So we subtract the bottom exponent from the top, which will give us 5 to the negative 1 over 1. Then we flip the reciprocal to make the exponent positive, and we get 1/5. Since 1/5 is equal to 1/5, this one is true. On C, we've got 6 to the 3rd to the 4th is equal to 6 to the 4th to the 3rd. They want to know true or false. These are power rules. So 6 to the 3rd to the 4th, you're going to multiply to get 6 to the 12th. 6 to the 4th to the 3rd, you're going to multiply to also get 6 to the 12th. Since they match, it is true. On D, 3 squared divided by 3 to the 7th, is that equal to 3 squared times 3 to the negative 7? Neither of these are in simplest form. I'm going to start with this one. 3 squared times 3 to the negative 7. I'm going to keep that base, which is 3. I'm going to add the 2 plus negative 7 to get negative 5, which becomes 1 over 3 to the 5th. Now, that still does not look like what we have over here. This is a quotient rule. If I subtract, I get 3 squared minus 5, just like I did here. And I end up with 1 over 3 to the 5th. Simplest form, 1 over 3 to the 5th and 1 over 3 to the 5th. This one is true. On E, 8 to the 0 over 8 to the negative 4, they want to know, is it equal to 8 to the negative 4? The first thing I see is that 0 exponent. If I change it to a 1 and compare these, is 1 over, 1 over 8 to the negative 4 going to be equal to 8 to the negative 4? It is not, because they are actually reciprocals of each other, which makes that one false. Sometimes you don't have to go all the way to simplest form just to see if they match. This one, you could easily tell it was never going to match. On F, 4 to the 10th divided by 4 to the 5th, they want to know, is it equal to 4 squared? This is a quotient rule. Remember, quotient means division, which means we're going to keep the base, subtract the exponents. 10 minus 5 gives me 4 to the 5th. 4 to the 5th is definitely not equal to 4 squared, making this one false. On number 6, write each of these as the product of a whole number and a power of 10. Now, the word product tells us to multiply, so they want us to multiply a whole number and a base 10. Describe this relationship between place value and exponents. Now, base 10 is directly related to scientific notation. Basically, that is what we are doing here. a whole number 3 times 10 to the 1, 2, 3 place values would give us 3 times 10 to the third. For 300, whole number 3 times 10 to the 1, 2 place values would be 10 squared. For 30, whole number 3 times 10 to the 1 exponent, because there was only one place value to move. For 3, that would be 3 times 10 to the 0, because we're not multiplying it by 10 at all. 0.3, this is where we slip into the negatives. 3 times 10 to the negative 1 exponent. 3 times 10 to the negative 2 exponents. And 3 times 10 to the negative 3 to represent 3 place values. Now, describe the relationship between place value and exponents. They are just showing you the pattern here on these. They're really wanting you to notice why that 10 to the 0 would have just become a 1, leaving you with 3 for your answer. Notice how each time you multiply by 10, it affected your exponential form, which made your numbers bigger or smaller.